Hello, in this video we're going to take a look at the properties of exponents and a couple of examples. Here we have the property of exponents. So, first of all, the first two properties is when the base is exactly the same. And for that, we will have a property for multiplication and another one for division. So, let's see the first one, the one for multiplication. If you have the same base and different exponents and its multiplication, what you're going to do is to keep the base and add those exponents. So let's see an example. Here we have the same base, which is 3. So, and its multiplication. So we're going to keep the base and add those exponents. 2 plus 5 is 7. So it would be 3 to the power of 7. Let's see with letters. It's exactly the same. If your base is the same and you have multiplication here, what you're going to do is keep the base and add the exponents. 3 plus 2 is 5. Let's see the second property. It's again, as I said, same base, different exponent, but division this time. If that's the case, you're going to keep the base because that's what's the same. And if it's division, you're going to subtract the exponents this time. So here we have division, same base, which is 2. So I'm going to keep the base 2 and subtract exponents. 5 minus 3. And 5 minus 3 is 2. The next one, again, I have division, I have same base, so we're going to keep the base and subtract exponent. 6 minus, I don't see any exponent here, so that means that exponent is 1. So this would be 6 minus 1. So this is p to the power of 5. Let's see the next one. Now this time that following two properties are when exponents are the same. And again, we're going to have a property for multiplication and one for division. So for the multiplication, bases are not the same here, but exponents are the same. When that happens, you're going to keep what is the same, which is the exponent. So you're going to keep the exponent, and since it's multiplication, you're just going to multiply those bases. So on my example here, exponent is 2, the same exponent. So I'm going to keep the exponent and multiply the bases. Multiply 3 times 5 and keep the exponent. 3 times 5 is 15 and I keep the exponent, which is 2. The next example is the same thing. I have the same exponent, which is 3, but different bases, and it's multiplication. So I'm going to multiply those bases and keep the exponent. Division. If it's division, you're going to divide the bases, and since the exponent is the same this time, you're going to keep the exponent. So let's see our example. I do have same exponent here, 5 and 5. So I'm going, and it's division, I'm going to divide those bases and keep the exponent. 6 divided by 3 is 2, and my exponent is 5. Same with letters here on my next example. My exponent is 6, is the same for both, is division. So I'm going to divide the bases and keep the exponent. The next property, power of a power. When you have a power raised to another power, what you're going to do is keep the base and multiply those exponents. So in my example, I have 3 to the power of 2 and all of that to the power of 5. So this is a power of a power, so you're going to keep the base and multiply those exponents. 2 times 5 is 10. Same on the next example. You have the power of a power, so you keep the base and you multiply the exponents. 6 times 3 is 18. Next property, power of 0. No matter what your base is, no matter what, if it's to the power of 0, that will be equal to 1. So in my example, I have 2,342 to the power of 0. No matter what, if it's to the power of 0, your answer is 1. So on the next example, I have like this big thing here, but it doesn't matter what you have here. If all of this, and we use parentheses to say all of this in algebra, if all of this is to the power of 0, then my answer is 1. Next example, when you have a negative exponent here, negative exponent, negative m. If that's the case, you're going to rewrite this because this is x to the power of negative m. This is like you have a over 1 here, right? You're going to rewrite this, but write it in the denominator and you change your exponent to positive. So here m is positive. So in my example, if I have x to the power of negative 6, if I want to change this to a positive exponent, this will be 1 over x to the power of positive 6. I change that negative exponent to a positive exponent. Again, on my next example, I have 5 to the power of negative 2. So if I want to change that negative 2 to a positive 2, I will rewrite that, but in the denominator this time, and change that negative 2 to a positive 2. Let's see a couple of examples on how we're going to work with these properties. Okay, my first example is a to the power of 3 times a. First thing that you need to recognize is that here you have multiplication and it's the same base. When that happens, property number 1, you need to keep the base and add those exponents. So this would be 3 plus 1, because if I don't see an exponent here, it's because my exponent is 1. And of course, 3 plus 1 would be a to the power of 4. The next one, I do have the same base, but this time is division. So I have to look at the second property for division and same base. And that property says if you have the same base and it's division, you keep the base and you subtract the exponent that is in the denominator. Okay, so this would be a, and 8 minus 5 is 3. So my answer would be a to the power of 3. I want to take a close look to number 3 because it looks pretty much almost exactly the same as number 2. And the only difference is that the 5 in the denominator, the exponent in the denominator, is a negative 5, not a positive 5 like here. But that will make a huge difference. Let's see that one. Okay, I do have division and same base, so I need to keep the base and subtract the exponent. So I'm going to keep the base and I'm going to subtract, so here's the subtraction, the exponent in the denominator. But the exponent on the bottom is negative 5. Did you see how I ended up with 2 negatives in a row? Because my exponent in the denominator was a negative exponent. Now, whenever I have 2 negatives in a row, that's a positive, right? So this will be a to the power of 8 plus 5, which is a to the power of 13. The next one, it's kind of the same problem, but now I have 5 on top and 8 in the denominator. Let's see what happens here. This is division and same base. So if that's the case, you're going to keep the base, and as the property says, you're going to subtract the exponent. So I'm going to subtract 8, the exponent in the denominator. This will be a to the power of 5 minus 8, which is negative 3. A negative exponent, but we do have a property for that too. When we have a negative exponent, it was the last property we just saw. We can write it as positive by writing it in the denominator. So this would be 8 to the power of 3. 1 over 8 to the power of 3. Let's see our next example. In this example, all of this is to the power of 0. When that happens, no matter what you have inside here, that will be 1. Our last example. I have a lot of things here, but I'm going to be doing variable by variable or letter by letter. So I'm going to take a look at the A's first. So here I have division and it's same base. So for the A's, I'm going to keep the base and subtract exponents, 4 minus 2. Let's take a look at B. Again, I have same base and division, so I'm going to keep base and subtract the exponent as always in the denominator. So let's do the subtractions now. 4 minus 2 is 2, and for B, 5 minus 3 is 2. So the answer for this problem is A squared times B squared. That will be all for this video. I hope you like it. Bye.